Alright, so let's talk about the final exam and review a little bit some questions that you should be familiar with and be prepared to answer in the final exam. Okay? As you're preparing for the final, you do want to download the checklist, the review checklist. Make sure you go through every bullet point and make sure you check it off that you know how to do that type of question. If you don't remember how to do that type of question, there are review questions or review exercises from previous things that we've already done in this class. Those type of questions are going to be similar to the type that you'll see on the final exam. Now, the final exam, it is cumulative. About 60%, between 50 and 60% will come from the two modules that we've done since exam 2. So 40 to 50% will come from material already covered in exam 1 and 2. Okay, so it's a little heavier weighted towards the end of the class, right? Okay, so I want to go ahead and do a few examples right now from Module 11 in this video. I think I have one example from Module 12 that I also will do in this video just because it's related to this main example here. And then in the next video I'll do a few from Module 12. Okay, so in Module 11 we have the normal probability distribution. Alright, so let's go ahead and read through this example. So the average final exam grades is 81%, standard deviation of 5. That's pretty good exam grades, right? Maybe this is what I hope for. So assume the final exams are normally distributed. Okay? So the first question I want to ask is, well, how would you find the probability that a randomly selected student scores more than 75%? More than 75. Okay? So first question, what is the probability that a randomly selected student scores more than 75? Alright? So that's the first type of question you should be able to convert to meaning this, and you should be able to solve this type of question. Okay? Another question I want to do in this video is, what's the probability that a randomly selected student scores less than 70%? Okay, so you should know how to do that. Lastly, you should know how to solve questions like, what's the probability that a randomly selected student scores between 70 and 75? Okay, so what's the probability that a randomly selected student scores between? Okay, so this is basically a right tail, a left tail, and a between type probability situation. You should know how to solve all of these. Now, I'll go through for this first one. Distribution of x is centered on the mean, which is 81. 75 is down here. And greater than 75, that means we're looking for that area there. Right off the bat, I know my answer should be more than 50% just by looking at that graph, because that's a symmetrical distribution. So you should always draw that. You should always draw that. It's a way to double check that your answer is going in the right direction, okay? So you want to convert this x to a distribution of z. So this is the distribution x. You want to convert it to a z. There is a z number right here for which these two areas are exactly the same. Right? So what's that conversion? I'll write it over here. Z equals x minus mu divided by sigma. Okay. So this is going to equal the probability that z is greater than x is 70. That's the number I want to convert, 75. Minus mu is 81, mean. Sigma is 5. Okay. What does that come out to be? Negative 2.1. Or sorry, negative 1.2. Negative 1.2. Okay, look that up in your table, right? So you should download the table that will be provided on the exam from Blackboard and practice using it. Okay, so negative 1.2. Alright, and look that up. And oh, you know what? That table value though is not my answer though, is it? Because remember this table is a CDF table. So it gives the probability that z is less than particular numbers, right? The back side. So if I want to know the forward side, what do I have to do 1 minus that value, right? So let me go ahead and write that down actually. So this is going to equal 1 minus whatever the table says. So flip the sign. So 1 minus, the table says 0.1151. So the answer is 0.8849. Alright, I won't always tell you guys to round these type of questions to 4 decimal places, but of course you should round it to 4 decimal places because that's the number of decimal places that is in the table. Okay, so don't round it to 3 or 2 or something like that. That doesn't make sense. Just keep whatever's in the table. Alright, so that's how to do this type of question. Moving on to the next one. So 80, what was it? 0.8, let me go and write it down. 0.8849, is that right? So that's a pretty good probability of scoring more than 75. Really good, actually. Alright, so now what's the probability someone scores less than 70? So, in our table, I highly recommend that you always draw this out. So 70, again, once again, less than 70. So see, I caught myself because I drew it out, so it's a good idea to draw it out. Less than 70, okay, so now I'm expecting this to be a smaller probability. I should expect my answer to be less than 50% because I should expect it to just be that little tail, right? So let's go ahead and, first thing, let's go ahead and convert this to a z. So 70 minus 81 divided by 5. So plug that into a calculator and you get 2.2. That's what I got. Negative 2.2. Negative 2.20. Okay, so this is equal to 0.0139, which is good. It's a small probability, and I would expect that just by looking at this graph that it would be small. It is. So okay, pretty low chance of scoring below a 70 on this exam. Okay. All right. What about between probabilities? In the middle I have 81. Okay, so now between 70 and 75. Okay, so strictly less than 81 would be 50%. So this is also going to be some number less than 50%, right? Just by looking at the graph, I can see that. Alright, so how am I going to find that probability? Well, just looking at the graph, if I know the probability that x is less than 75, right, all of that, and if I subtract off this probability that x is less than 70, then I'll be left with what's in between. Does that make sense? So if I take less than 75 and subtract off less than 70, I'll be left with what's in between. So let me go and write that down. So this is equal to the probability that x is less than 75 minus less than 70. Okay, so even though this looks like what you saw in part A and B, be careful that on the final exam, if you see a question like this on the final exam, don't just plug in chug, right? Okay, these are not the same thing, so be careful about what you're doing. So this says probability x is less than 75, that says more than 75, so it's not the same. Okay, so actually, let's go ahead and just redo our z values. Now the z value, when you plug in 75, is going to be, the same, obviously, negative 1.20 for 75, just like it was for A, right? And for 70, it will be negative 2.20. Okay? So now if you look up these values in the table, you get 0.1151 and 0.0139. Right? You subtract those two, and you get 0.1010. Right? So probability that a student scores between 70 and 75 is 0.1010. Okay, so all these type of problems is asking you to find the probability, right, given a random normal distribution. Now let's flip it around and let's ask for a percentile this time. You should also be able to answer questions where you have to find a percentile. Okay, so it's basically doing these type of problems in the reverse direction, where I know the area and what I'm trying to do is find the different x values. Okay, so problem D. Let's see. So for problem D, so a teacher promises to pass out candy to students with the top 3% of final exam grades. All right? So find the min grade a student needs on the final exam to get candy. All right, so that's the question. So find the top 3% of this distribution, basically. In other words, you could have said find the 97th percentile. That's the same thing as finding the top 3%. So I'll write that down here. Find the 97th percentile. Okay. You want to find, here's 0.03 down here, right? Which means 0.95 is back there. And whenever you refer to percentiles, usually you prefer to the bottom, less than percentile. Unless you were to say, find the top 3 percentile. You could have also said it that way. Okay. But if there's no one says bottom, that's just inferred. Okay. So basically what we want to know is, here is in the center 81. What's the minimum grade that you need in order to get candy? Everyone's going to get candy if you're in the top 3%. All right? So what's the minimum grade that you need to get candy? All right? So you see, I have the area. What I need to know is what's the x value. Right? And we have this equation, z equals x minus mu divided by sigma. Right? So this is a distribution of x of a of a student's final exam, x grade. X is your final exam grade. And we need to, we have the table which is centered on 0, so we need to consider the distribution of z. Right? And so we need to first find what is this z value, which has 0.97 behind it and 0.03 in front of it. We need to find what is that z value, and then we'll go from what is that z value to figure out what that x value is. Okay? So, all right, starting with what is that z value. What is that z value? So behind is 0.97. We want to use the behind area because the table gives us the behind area. So I want to go inside the table and look for 0.97 and find the corresponding z value for that. Okay? So I look for 0.97 inside my table, and I have 1.88 is 0.9699. Choose the value that's the closest. You're not going to get exact. Well, sometimes you do. If you get exact, that's great. If you don't get exact, choose whichever one is closer. So 1.88. So this is 1.88. And it's positive. That makes sense because it's in front of the 0. So by drawing it out, you make sure you're kind of going on the right track. All right, so this is 1.88 equals x minus mu is 81 divided by sigma is 5. All right, rearrange this equation, solve for x. So 1.88 times 5 plus 81 equals x. All right, just doing some algebra there. If you do that, you should get 90.4 equals x. So anyone who scores above a 90% gets a piece of candy, right? Okay, so I'm going to do one more example using this example. This one is actually coming from module 12 though. Okay, so all this stuff that we just did was module 11. Here's one example coming from module 12. All right, so module 12, one of the things that you need to know, kind of builds on this normal distribution, is the central limit theorem, or finding a probability for a sample mean, right? So let us now do a question where we have a class of 50 students. All right, so let's see, this would be part E, I guess. So we have a class of 50 students who take the final exam. Okay, so 50 students take the final exam. Find the probability that their average grade, so when I write this, I'm not going to just write X, but it's a probability for X bar, sample mean. Okay, that their average grade is more than 83. Alright, so this is a central limit theorem type question because we have average instead of just finding the probability that a randomly selected student scores more than 83. It's the probability that the average for all 50 students is more than 53. Okay, this changes the conversion to Z. Otherwise, everything else stays the same. Okay, so let's see. When I do this conversion, so I always like to draw it out. Here in the center is 81. More than, here's 83 is over here. More than 83 is this area here. Okay, so I'm expecting a rather small probability, right? So let's see. Let's go ahead and first thing I want to do is convert this. So this is distribution of X bar. So this is my X bar value that I want to convert to a Z value. So 83 minus mu is 81, sigma 5 over square root of 50. When you're plugging this into your calculator, don't forget to put the denominator in parentheses, otherwise your order of operations is going to be all messed up. So make sure you get the same number. So when I calculated that, I got 2.83. So you should get that same Z value. Okay. So go ahead and calculate that. Make sure you get the same thing. All right. So of course, table tells me the area behind. So if I want the area in front, I'm going to have to do 1 minus whatever value I get in the table. Okay, so in the table, when you look up 2.833, you should get 0.9997, or sorry, 0.9977, which is 0.0023. Alright, so probability that the class scores more than 83% is really unlikely. For the probability that the average for all 50 students is more than 83 is only 0.0023.